question 7 in the June 23 A-level paper 1, what we're looking at here is functions. So for part A, I need to state the range of f for this function. Now, it tells us that x must be greater than 2, so the minimum value I want to be able to put in here is 2 to see what it's got to be bigger than. So f of 2 would be 3 plus root 2 minus 2, which is 3. So therefore that's telling me that's not, we can't enter 2 because x has to be bigger than 2, but that tells us then that our function output must be greater than 3. And that's going to become important a little bit later on as we get through these questions. These functions questions, they really test your understanding of what your inputs and your outputs can be. So it's really important that you look at this carefully. Okay, for part B, I need to find the inverse function of f, and the technique we use to do that. So if I write out the original function first. Now, when you're finding an inverse, you're in effect switching the output to the input and the input to the output. So if I swap those over, that becomes x, and I'm finding the inverse function, so that becomes f dash of x. And what you want to do is make f dash of x your subject, so you can then you fully switch your inputs and your outputs. So subtract 3 from both sides first. And then square both sides. That gives us x minus 3 squared on this side equals f dash x. And then you just need to add 2 to both sides, and you've got your inverse function, which will be x minus 3 squared, and I needed to add 2 to both sides. So that gives us our inverse function. Now, for part C, it tells us about another function g, and we need to find this composite function g of f of 6. So let's work out f of 6 first. F of 6 will be 3 plus root x minus 2. Sorry, we're going to switch that x with 6, aren't we? So that gives us 3 plus root 4, which will give us 3 plus 2, which is 5. Now you might be thinking the square root of 4 is plus or minus 2. So can I use 3 minus 2 here? Well, the issue we would have with that would be that our output would be 1, and as we've already stated here, the range of f of x must be bigger than 3, so therefore this one is invalid. Now we next need to work out g of f of 6, so I want to work out g of 5. If we work out g of 5, that will be 15 over 5 minus 3, which is 15 over 2, which is 7.5. And that gives us the value of g of f of 6. Now, the last bit here for part D says find the exact value of the constant a for which f of a squared plus 2 is equal to g of a. So let's set that up as an equation. So f of a squared plus 2 will be 3 plus the square root of a squared plus 2, and then we need to minus 2 as per the function. So that gives us 3 plus square root of a squared. Now if you square root a squared, again you'll get plus or minus, and again we can use 3 plus a because we know that our output must be bigger than 3. We can't use 3 minus a because whatever minus a is, if it's a non-zero value, it's going to be less than 3 and it would be invalid for this function. So from there I now need to set that up as an equation. So when is 3 plus a, which is f of a squared plus 2, equal to g of a, which is 15 over a minus 3, switching our input to a from x. Now I just need to solve this equation, so if I multiply both sides by a minus 3, it gives me a minus 3 times a plus 3, which you should recognize from the difference of two squares. That would be a squared minus 9 equals 15, so a squared is 24. And if a squared is 24, a will be the square root of 24. Can I write as a decimal? Well, it's asked me for the exact value. What I can do, however, is simplify that from root 24 to 2 root 6. And that will be my final answer.